This video explains the application layout and key concepts of Thermo-Calc software. This is how the software looks the first time you start the program. The application is divided into several panels, but most of your interaction will take place in 3 of them. The first is the project pane, where you create and change relations between activities. The center pane is where activities are configured. For example, this is where you select elements and set temperature, pressure, compositions, diagram axes, and so on. The rightmost pane is where results are shown in the form of tables and plots. Let's start in the first pane and focus for a while on the concept of activities. In Thermo-Calc, you are always working with a project, which is represented by the project node. Below that, you will create a sequence or map of activities. There are different types of activities, and each activity is represented by a folder or node. For example, there is one activity for defining your alloy system, one for setting up calculations, and one for plotting results. I will manually create one of each activity and explain what I'm doing. There are a variety of ways to create activities, and in this video, I'll show you 2. For this example, I'll set up a calculation of the iron-carbon phase diagram and talk you through the whole procedure. Start your software so that you can follow along. We will begin by right-clicking on the My Project Activity node. When you right-click on any of the nodes in the project pane, a context-sensitive menu appears that shows what can be performed in that activity. To start a new project, right-click on the My Project Activity node and select Create New Activity, then System Definer. A new node appears in the project pane that is used for setting up the system. You can also see that the center pane was replaced with a periodic table. This is the configuration for System Definer. It's where you select your database and elements, open a material file, and select or deselect phases. We'll use the FE demo database and the elements iron and carbon. For this example, we'll use the default values for everything else, so that's all we have to do in the System Definer. Now we want to add another activity, so I'll go back to the project pane. This time, I right-click on the System Definer node, highlight Create New Successor, and choose Equilibrium Calculator. An Equilibrium Calculator node appears in the project pane, and the configuration window changes again. Here we define which calculation type we want to perform, so we select Phase Diagram. This will cause the axis definitions to appear. If you have an older version of Thermo-Calc, the axes are already present, but you may need to check the boxes to their left to enable them. Once again, we'll accept the default values that the program gives us. Make sure your values match mine before moving on. Finally, we'll want to plot our results once they're calculated, so we need to create one more node. You could go back to the project pane and right-click on the Equilibrium Calculator node, but I will show you a different way. If you go to the bottom of the configuration window, you will see a button called Create New Successor. When you click on this button, a list of the available activities comes up. We want to plot our results, so we select Plot Renderer. Just as before, the new activity appears in the project pane. The configuration window has also changed again. Here you can configure the plot by changing things such as the axis variables, axis type, and scaling. We're going to use the default variables, so we won't change anything. You may have noticed that the plot was also assigned a tab in the results pane. The table is currently empty, but the results will appear once the calculations are complete. Now we have configured all the activities, so the next step is to perform them. Performing an activity means that the activity operates on the configuration and produces a result. The program starts with the top node in a project, completes the configuration, then sends the information to the next node, which in turn uses the information for its calculation, and so on. Now let's perform the plot. To do this, you can either click Perform at the bottom center of the screen, or you can go back up to the project pane and right-click on the plot node. Notice that here you have the option to either perform now or perform later, which allows you to perform the calculation at a later time. This is helpful if, for example, you have a time-consuming calculation that you want to run overnight. We will choose Perform Now, so I will cancel the timer and click Perform at the bottom of the screen. When you perform an activity node, all the nodes above it in the sequence will also be performed. You may notice that there is activity happening in two windows we haven't looked at yet. The first is the scheduler, an area that shows the projects that are currently being performed, as well as projects that are scheduled to be performed in the future. The other is the events log, where you can find information about ongoing calculations, warnings, and error messages. The events log can be especially useful if a calculation is not working as you assume it should. Once the calculations are done, the plot will appear in the Results tab. Here you can zoom in and out, configure the plot to your liking, and export the images in various formats. There are a few helpful items I want to show you. From the Help menu, you can access the online help system, which includes all of our documentation for Thermo-Calc, add-on programs, and the databases. The online help system is fully searchable and cross-referenced for easy use. The program opens in an internet browser, but the files are stored locally on your computer, so you do not need an internet connection to use it. All the documentation is also accessible in PDF format from the Help menu, Open Manuals folder. The software also includes many examples calculations, which you can find in the Help menu, Open Examples. The examples are divided by thermodynamic, which includes the property model calculator, precipitation, and diffusion. To run an example, simply open the folder you want and double-click on the example. A fully configured calculation will load. To run the calculation, right-click on the top node and select Perform Now. Many of these examples have videos explaining the calculation, which you can watch at thermocalc.com, Training, Video Tutorials. To access the console mode examples, select the Switch to Console Mode button and open the Examples folder again. Another feature that will help you get started is the templates located on the home screen. When you select a template, all of the nodes you need to run that type of calculation will appear in the project pane. Configure each of the nodes and then run the calculation. There is one final feature I want to show you. Thermo-Calc allows you to save notes with your projects. Simply click the button at the bottom center of the screen with the white piece of paper, and a box will appear where you can record information. I will make a quick note about this project and then click OK. Notice that the white paper icon now has lines on it to show you that this project includes notes. Your notes will save with the project they were created in, so they will be available every time you open this particular project. Finally, you can save projects to come back and work on them later or share them with others. You can either click the Save icon or use the File menu to select Save Project or Save Project As. The software will automatically prompt you to save your project when you exit the program, so you won't risk losing any work. As a next step in learning Thermo-Calc, we recommend that you use the graphical mode examples included in your software to learn about the various calculations. Follow along using the examples guide included in your software by going to Help, Open Manuals folder, and selecting the Graphical Mode Examples Guide. And watch the companion videos which walk you step by step through setting up the calculations and can be found at thermocalc.com, Training, Video Tutorials.